Howdy everyone, it's Miss Kosh. I wanted to work this spring problem with you. So what they have here is they're saying a weight hanging from a spring is set in motion by an upward push, which means that it goes up first and then it comes back to the equilibrium and then it goes down and then up and it's doing that sort of thing. Okay, so graph the equation, label the axis. Now on this one, it takes 5 seconds to complete one cycle of moving from its equilibrium point to 8 centimeters above, then dropping 8 centimeters below. You know what? This may be exactly what's on the homework. I'm going to change it. You can do this with me. Let's change this. I think it was 8 on the other one. Let's go with 6, just so that you have practice writing another problem, but whatever. Okay, so they're telling us it takes 5 seconds to complete one cycle from moving from equilibrium. And finally, okay, so they didn't exactly tell us when t equals 0, but let's just, so because they didn't, there's more than one correct way to do this problem. And I think in my previous video I said, as long as your graph and your equation match each other, it's okay if they weren't exactly the way that I thought through it. You know what, they also said 5 seconds on the previous, this problem shows up in the homework, my bad. Let's say it takes, you know what, my birthday is 6/17. So let's just change that up just to be different. And okay, so if that takes us, and I wanted to use an odd number because the problem before was odd. So if it's at time 0, it's where it starts, and then it's going to come up, and then come back to 0, and then go down, and then come back to 0. This point right here is going to be after one cycle, so that's at 17 seconds. It's a very slow-moving spring. Oh, you know what? Let's go ahead and say t equals, my bad, t equals 17, and so half of 17 is what, 8.5? And half of that is when t is equal to 4.25. So then this one down here is going to be 12.75. How well am I at adding? If I add 4.25 to that, yeah, I'm at 17. Okay, we're good. Okay, so, and then our heights, those were our times. Well, our height here, they don't tell us if it's hanging from a certain thing, and so it's all going to be negative. Let's just say that this is at a height of 0. Then this one is at a height of, what did it say, 6 centimeters above. Then we're back to a height of 0, and then we're at a height of -6, and then we're back to a height of 0. Okay, so our graph would look something like this. Pretend I can draw. Well, I've done worse. Okay, let's label these points. This obviously is 0, 0. We have 4.25, comma 6. We have 8.5. Oh, what am I doing? Comma 0. And then we have 12.75, comma -6. And then we've got 17, 0. Okay, so find a sinusoidal function. Doesn't that make you sound fancy? It's just a sine curve. Find a sinusoidal function to represent the motion of your moving weight. What is your independent variable? Time. And then your dependent is the height. What is the amplitude? In this particular case, we go up 6 and then down 6. What is the period? Okay, the period is 17 seconds. And so then we need to find, b. Oh, my bad. So 2 pi over b equals 17. So that means 2 pi equals 17b, which means that b is equal to 2 pi over 17. Yes, that's gross, but better to do the gross example in the video rather than leave it to you on your own. Okay, so what I see here is a sine curve. So I can always write it as cosine, I can always shift it, but I'm going to do the most efficient thing, or the laziest thing. I'm not lazy, I'm efficient. And so we'll say the height as a function of time is equal to, our amplitude was 6. This looks like a sine curve. Our b value is 2 pi over 17. Here's t. And then we didn't need to shift up or down or left or right or anything. We're done. Use the function from a. Well, how about from D, because that doesn't make sense, to predict the height of the weight after 3 seconds. Okay. Yee. All right, so after 3 seconds, what we'll do here is we have h of 3 is equal to 6 sine of 2 pi, well, 2 times 3 is 6. So this is going to be 6 pi over 17. Oh, there's my birthday, 6/17. That is not on the unit circle. I would not expect you to know how to do that. So let's see, do I have Desmos open? I do. What did we just say? And then I forgot. 6 sine of 6 pi over 17. All right, 6 sine of 6 pi over 17. And there's our value, 3 point, you know what, okay. Oop, come back. H of 3 is approximately, I just forgot. Well, I'll post it right here. Sorry, in a perfect world, these videos would be better. It is so not a perfect world. So 5.371. And what are our units? Centimeters, there we go. Okay, in the first 5 seconds, when will the height of the weight be 4 centimeters below the equilibrium? Okay, so they're saying basically, when does this equal 4 here and here? Negative 4. So let's plug that in and see. You know, this does show up in our example. It was the same, or in our homework. And you can use the unit circle for the homework one, but I don't think you can use the unit circle for this. Let's just see. So basically, h of t is equal to 6 sine of 2 pi over 17t. Is that right? Yeah, that was our equation. We want to know, when does this equal negative 4? Because it's 4 centimeters below. All right, so this, here's what I see. I see that I'm getting to sine of 2 pi over 17t is equal to negative 2/3. Negative 2/3 is not on my unit circle, so I'm not even going to try. So what I can do is I can go to Desmos, and I can do sine, well, maybe I need y equals, maybe I don't, but equals sine of 2 pi x over 17. Oh, good grief. And then I want to know when that equals, when does y equal negative 2/3? Did I remember that correctly? Well, oh, good grief. We can, sometimes when I don't, that's just annoying. We wanted to know within the first 5 seconds, so let's go from like negative 1 to 5 seconds, so let's say 7. And then this was, we need to know when does y equal negative 2/3. So let's go from, oh, you know, I didn't even type in the equation that they gave us, but that's okay. I'd already cleaned it up. Let's go from negative 1 to, not 49, that seems silly, to 2, and see if that's any good. Oh, okay, well, here, hide. Okay, well, that wasn't quite good enough. So what they're telling us is, hang on. In the first 5 seconds, when will, oh, you know what? That was because it took 5 seconds before, so my bad. Let's change this to the first 17 seconds. I changed the problem halfway through, my bad, it happens. Okay, so now we can see that it's this value and it's this value. So let's bring that back in here. And so that, when did that happen? No, okay. At 10.474. And the other one was 15.026. Okay, so hopefully between the, I think I now have 4 videos for you. So I have this one that I just made. I had this one I did a few years ago. This one, I had an easier version from a few years ago, and then I made another video of this that's a little more complicated. So hopefully you understand what's happening. Go practice. Good luck. Let me know if you have questions.